Hello everyone, today let's take a look at QP115 asking us how many positive integers less than 1000 are not divisible by a one-digit prime. So obviously we have 1000 numbers between, basically we start at 1, we go all the way up to 1000. We have 1000 numbers between 1 and 1000. And our one-digit primes are obviously just going to be 2, we have 3, we have 5, and we have 7. Now it's asking us about integers less than 1000, but we can just basically include 1000 because it is going to be divisible by a one-digit prime, so it's not going to get included in our final count regardless, right? And doing so is just going to make the calculation a little bit easier. So I have 1000 numbers here. I need to subtract off all the numbers that are divisible by a one-digit prime. So how do I calculate this right here? Well, it's just basically going to be all the numbers that are either divisible by 2, or they're divisible by 3, or they're divisible by 5, or they're divisible by 7, or they're divisible by any combination of those types of numbers. For instance, 6 is divisible by both 2 and 3, etc. So we're basically counting this set right here, right, where these events 2, 3, 5, and 7 mean that the number is divisible by that element. And we just proved the inclusion-exclusion formula, right? We know that this is going to be equal to all of the numbers that are divisible by 2 plus all of the numbers that are divisible by 3 plus all of the numbers that are divisible by 5 plus all of the numbers that are divisible by 7, and then we minus all of the pairwise overlaps, right? So we do minus the numbers that are divisible by both 2 and 3, right? Minus the numbers that are divisible by both 2 and 5, etc. And then we're going to basically end up adding back on the triple intersections and then finally subtracting off the quadruple intersections, right? So there should be a solid amount of calculations here, but nothing that we cannot do, right? So first of all, let's just calculate the numbers between 1 and 1000 that are divisible by 2. Obviously, my numbers that are divisible by 2 are going to be 2, 4, 6, 8, right? All the way up to basically 1000, right? And how many of those numbers are there? Well, half the numbers between 1 and 1000 will be divisible by 2, right? So 1000 divided by 2 will give us 500 numbers that are divisible by 2. This is the magnitude of the set that we are calling 2. Now, the magnitude of the set of numbers that are divisible by 3 is going to basically just be the floor of 1000 divided by 3, right? It's going to be the floor of that, which ends up being 333. You could also think about it like 999 will be the last number that will be divisible by 3, and when we divide that by 3, we get 333 numbers that are divisible by 3. Now, the magnitude of the set 5, all the numbers that are divisible by 5, well, we have 1000 numbers. We divide that by 5, we get 200 numbers that will be divisible by 5. Then for the magnitude of numbers that are divisible by 7, again, we're going to take the floor function of 1000 divided by 7. That's going to end up being 142. You could also think about it like this. 994 will be the last number that will be divisible by 7. That is less than or equal to 1000, right? So when we divide that by 7, we get 142. So those are the magnitudes of all of our single intersections, right, are right here, 500 plus 333 plus 200 plus 142. That's going to end up equaling 1175. So the magnitude of these right here will be 1175. Now we need to subtract off all of our double intersections. And now for our double intersections, they're going to be 4, choose 2. They're going to be 6 different double intersections that we have. So let's just go through and do all of them, which we're going to have to do. So 2 intersection 3, that just means that it's going to be divisible by 6. We could just call this the magnitude of the set 6. This right here, the numbers divisible by 6 will be 1000 divided by 6, and we take the floor function of that, which will give us 166. Numbers divisible by, now let's do 2 and 5, right? That means it's going to be divisible by 10. That's obviously just going to be 1000 divided by 10. There's going to be 100 of those numbers. Now let's do 2 intersection 7, which basically means we are divisible by 14, right? We take 1000 divided by 14, take the floor function of that. That's just going to give us 71 here. Now let's keep doing these. Let's do 3 intersection 5 now. That means we are divisible by 15. We again just take the floor function of 1000 divided by 15. When we do that, we're going to just get 66. Now let's do 3 intersection 7. We're getting close here. I'm sorry, but we just need to do a few more. So 21 we have. Floor function of 1000 divided by 21. That's going to just give us, it's going to give us 47. Now just one more double intersection. It's going to be 5 intersection 7. That means the numbers both divisible by 5 and 7, right? So that means it's going to be divisible divisible by 35 when we multiply these two numbers, right? We take the floor function of 1000 divided by 35. Again, like we've been doing this whole time, we're going to get 28. Now, when I sum up all of these numbers, all of our double intersections, I'm going to get 478. So we're subtracting off for our double intersections 478. Okay, now we still need to add back on the triple intersections, right? This is inclusion, exclusion. So there are going to be 4 different triple intersections, right? 4 choose 3. So first, let's start off with 2 intersection 3 intersection 5. That just means the number is going to be divisible by 30, right? When we multiply all 3 of these. When we take that floor function 1000 divided by 30, it's just going to be 33. Now let's do 2 intersection 3 intersection 7. So 6 times 7, that's going to be 42. All the numbers divisible by 42. Same floor function, we're going to get 23. And now let's do one more. Let's do 2 intersection 5 intersection 7. So that's all the numbers divisible by 70. Same thing, when we take the floor function, we're going to get 14. And now our final triple intersection is going to be 3 intersection 5 intersection 7, right? So these are all the numbers divisible by 105. Same floor function, we're going to get 9. Now, when I sum all of these up right here, all of our triple intersections, that's going to give me 79. So we need to add back on 79 here. And now finally, we just need to subtract off our one quadruple intersection, right? That's going to be the intersection between 2, 3, 5, and 7. The numbers divisible by all 4 of them. 2 times 3 times 5 is going to be 30, and then 30 times 7 is going to be 210. So all the numbers divisible by 210 between 1 and 1000, of which there are 4. So now we just have to subtract off this 4 for our quadruple intersections right here. Now the inclusion exclusion is done, right? I have all 4 terms right here. When I sum those up, I'm going to get 772. So I have 772 numbers that are divisible by at least one of 2, 3, 5, or 7. And that means that the number that are not divisible by any of them, we just take 1000 and we subtract off 772, which will just give us 228, which will be our final answer. Here's just going to be a lot of computation, but a pretty simple application of inclusion exclusion. And again, this is our final answer, 228.